All right, hi everybody. Today is the first day that we're going to try to take some notes at home online. So this is our first of example questions, and we are going to be doing section 2.1 to 2.4, solving equations. Now, one of the things I want you to do is take a minute, pause the video, and write yourself a little summary of what we talked about in class today. Maybe look back at your notes, but try to condense it to a couple of sentences on what is it that we're supposed to be practicing in these examples. So do me a favor, pause the video, and then do that. Okay, now that you've paused your video, we're going to go over a couple of example problems that you might have done. So our first example is going to be a one-step equation. And remember, one-step equations can be addition or subtraction or multiplication or division, but only one of those four things. So our example today is going to be x over 4 equals 9. And how would we solve that? So the first thing I want to talk about is that fractions with the variables on the top are really like fractional coefficients. So we could really write this as 1/4 times x equals 9. Okay? And then from there, we're going to go through and we're going to do the opposite of 1/4. And usually the opposite of division is multiplication. That's true this time also, since it's a fraction. We're going to multiply both sides by 4, which is going to cancel out our fraction in the front and leave our x isolated. What's 4 times 9? Well, that's 36, and 36 is our answer. Okay. Next up, we're going to do a two-step equation. And if you remember, two-step equations are ones where you have multiplication and addition, or multiplication and subtraction, or division and subtraction. A combination of two of the four operations. So our two-step equation today is going to be 1/2 times a plus 5 equals 18. Remember, when you're solving multi-step equations, 2 or more steps, that you'll want to undo in reverse order of operations. So for this particular letter, we would normally multiply first, multiply by the 1/2 if there was a number there. Instead, we're going to go backwards and we're going to get rid of the 5, which would have been our last order of operation. The other way you could think about this is to get rid of the number that is farthest away from the letter A. The 1/2 is closest to the A, so we're going to get rid of the 5 first. Okay, so I'm going to subtract 5 on both sides. That's going to give me 1/2 A on this side, and we're going to do 18 minus 5 to get 13. Now we have a problem just like our example 1, where we're trying to get rid of that fraction and isolate our variable. So I'm going to multiply by 2 on both sides, and I'm going to find out that A is equal to 26. Okay. Question number 3 is going to be justifying and working on distributive property. And we're going to work on distributive property in the next one too. Okay. So our equation here is going to be -8 times 2x minus 1 equals 36. And for each of these steps, I'm going to write down what property or what rule might allow me to complete that step in the process. So if my first step is going to be to multiply the -8 times both terms in parentheses, that's going to be distributive property. So I'm going to get -16x plus 8 equals 36, and that's made possible by the distributive property. This column on the side here is where we're going to justify all of our steps. Okay. All right, so now we have a two-step equation, and we're going to subtract 8 from both sides. That's going to be our subtraction property of equality, and 36 minus 8 is going to give us 28. So subtraction property of equality. And then we're going to divide by -16 on both sides. And we're going to end up here with a fraction that we need to reduce. So 28 over -16 is both divisible by 4. And so that's going to give me -7 over 4. That was division property of equality because I divided both sides by 16. Okay, so distributive property to solve, but then adding in that justification step on the side where we explain what property lets us do the steps that we're doing. Okay. And our last example today is going to be, what do you do if you have terms on both sides of your equation? So I have an equation that's 5g plus 4 times negative 5 plus 3g equal to 1 minus g. So you'll notice here that we have kind of a lot of things going on. And the first thing I want to get rid of is those parentheses. And then I'm going to combine my like terms on one side. Then I'm going to move all my terms from one side to the same side, all the constants on the other side. Then I can go through and use my inverse operations. Okay, so my first step here is to do my distributive property. So I have 5g minus 20, because positive 4 and negative 5 make a negative number, and then plus 12g, remember you're distributing to both terms, equals 1 minus g. Okay? Then on the left-hand side, we're going to take our 5g and our 12g, and we're going to combine those like terms. So I'm going to get 17g minus 20 equals 1 minus g. Now I have two g's, one on the left side, one on the right side, and I want them both on the same side. For this, I'm going to add my imaginary 1 there in front of my g, so I remember what I'm doing. And I like to combine both my like terms where the coefficient for my variable would be positive. So for me, that's adding 1g to both sides, because I'm then going to get a positive 18g. Okay? Now I have a two-step equation, so I'm going to add 20 to both sides. And so I'm going to get 21 over g. Divide by 18. Don't forget to simplify that fraction. Divide them both by 3, and you should get 7 over 6 as your final answer. All right, ladies, so at the end, what I'd like you to do is go through and fill out how you're feeling after seeing the examples and after doing the notes together. We probably should have done one at the beginning too. Sorry, I forgot about that. I'll try to remind you in the next video. But for right now, fill out that bottom little chart and tell me how you're feeling about solving any kind of algebraic equation, so that when we come back together next class, we have a better idea of what we need to work on. All right, see you next time.